Bright Tuty. Every student matters.
Is equal fractions, and we are also going to learn how to write a particular fraction in the simplest form. Okay, so let us begin with our today's lesson, that is starting with the equivalent fractions. The word equivalent, as the word says itself, equal. So what sound comes when you read the word equivalent is the word equal. So this is what equivalent fraction stands for. The fractions that are equal. Okay, let us read its mathematical definition. It says equivalent fractions are those fractions which represent the same part of a whole. Okay, same part of a whole, but it is written in different ways. Look here in the images in front of you. All the images that you see, they are different, but they are equivalent fractions. Why? Because they represent the same part of the whole. Look at the first image. Just consider how much part do you see is colored. I'm sure you can see that half of this particular figure that is shown, it is colored. Don't look at these fractions at the bottom here. Don't look at these fractions that are mentioned down there. I'll just hide them for now. Okay. Just don't look at these fractions. Just look at the images. What do you see? In the first one, how much part do you see is shaded? I'm sure you can say half part is shaded, right? Similarly, in the second image, that is in blue, how much part do you see is shaded? Clearly, half of the circle is shaded. In the third one, again, half of the circle is shaded in yellow, and the last one is also shaded half. Is that right? So we can write that each of these fractions, they are half. Okay. Now, I'm sure that you know how we are writing a particular fraction when it is divided into different parts. So the first one that we see, we clearly see it is divided into two parts. And out of two parts, one is shaded. So how do we write it? We write it as 1 over 2. It's right. Now look at the second one. How many parts do we see shaded? Out of the total number of parts, we see 2 parts are shaded out of 4 parts. So we write it as 2 over 4. The next one, how many are shaded and out of how much? So 3 are shaded out of 6. In the last one, how many are shaded? 4 are shaded out of 8. Is this clear? Do you see that every time we are writing different fractions, but as we have already discussed, all of these fractions, they are basically representing the same image where we see that half of the circle is shaded. Okay, I hope this is clear. The concept of equivalent fractions, it's basically different fractions which are representing the same part. Okay, now let us move ahead and see how we are going to classify whether a given fraction is equivalent or not. Okay, let us read here. It says R 1 over 3 and 2 over 7. We are just discussing the first part here. Are these equivalent? And we need to give reason. So think about this. If you have got a particular block, say this is a block, okay, let's divide it like this. If I divide it exactly into 3 parts, okay, and now imagine I'm going to divide the same kind of a block into 7. So say this is 1, so say this is 2, 3, 4, 5, 6 and 7. Okay, now let me shade one part out of 3. Okay, I have shaded one part out of 3. In the second one, I need to shade 2 parts out of 7. Okay, so I'll shade 2 parts out of 7. Now, do you see there is a small difference between the two? Right? There is a very small difference. If you will clearly draw an accurate image, you will clearly see that 1 over 3 and 2 over 4, 2 over 7, they are obviously very much not equal to each other. Here, clearly these two are not equivalent to each other. Okay, moving to the next one. It is 2 over 5 and 2 over 7. So clearly think about this. Here again we'll draw a box. I'm again mentioning this. This is a rough diagram. When you do it, make sure that you measure these blocks very carefully, because only then you can land up to a correct answer. So if I draw 1, 2, 3, 4 and 5, and I draw 1, 2, 3, 4, 5, 6 and 7 boxes. So what do I notice? If I shade 2 parts out of 5 and if I shade 2 parts out of 7, so clearly these two are not at all looking equal to me. So again I'll say that this particular pair, it is not equivalent. Now let's look at the next one. It is, I'll just erase this part from here, okay, so that I can have more space for the other one. So here it is 2 over 9 and it is 6. What have I written? It is 2 over 9 and 6 over 27. Okay, so let me, this time I'm just going to do one thing here. I'm going to insert a clear image. So let me just put a square here. Okay, so here comes the square. Okay, and let me just divide the square into certain parts. So I'll just put another box in here. Let me just shade it into white. Okay, so here we have clearly 2 boxes. So the upper box we are going to divide it into 9 equal parts. So let me just choose the black color. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, now the next one says that I need to draw 27 boxes. Now it's really difficult for me to draw with a rough hand how I can make 27 boxes. Let me just try, or I'll just do one thing. I'll just put an image here for you. Okay, so now what we have in front of us is a table that is very much a particular image, a pictorial representation of 2 over 9 and 6 over 27 we are going to represent in this. So in the first box, the table that you see in front of you, you have got 9 divisions in it. So out of these 9 divisions, we are going to shade out how much? 2 out of it. So if we shade 2, I'll just use some darker color. Okay, not visible. Red. Okay, so if I'm shading 2 parts out of 9. Okay, so here I have shaded 2 parts out of the 9 boxes that I have made. One thing to be very clear, do you see that here both of these boxes, they are exactly equal in size, right? They're exactly equal. However, the divisions are different. Okay, as in the one above, the line that you, the divisions that you see, they are a little broad. They are just 9 in that particular size, and the lower one, it has got 27 smaller divisions. So out of 27 we are going to shade 6 of them. So 1, 2, 3, 4, 5 and 6. Now what do we observe? We observe that equal number of boxes are shaded out of the whole in both of these images. So what we notice from here is that yes, this particular fraction given, out of these 3, this wasn't equivalent. Only this one here, that is 2 over 9 and 6 over 27 is equivalent. Okay, now they're saying give examples of 4 equivalent fractions. So let us write some examples of equivalent fractions. We just learned that if it is half, okay, we are just writing for half, or let us write for say 1 over 3. Okay, out of 3, if I've got 1 part. Okay, so if I've got 2 parts, then how much should be? Just imagine out of 3 you have got 1 part selected. So out of 3 Out of 6, if you have got 2 parts selected, it will be equivalent. Now say out of how much if 3 are selected, it will be 9. Just look how corresponding we are just going. So if it was 3, it was 6. If it was 6, we were at 9. So it's 1, 2, 3. Then if I'm at 4, what do you think the denominator needs to be? Just think about 3 more, right? So it will be 12. So we have written 4 equivalent fractions by adding 1, 1, 1 at the numerator, and we are taking the jumps of 3 at the denominator. Well, I think what we have learned about equivalent fractions is that it is very difficult to compare between these equivalent fractions if we are making so much efforts in drawing these boxes, then coloring them out, then comparing them. So it's really a very tough job. So there must be something that is simple to do. Okay, we are going to learn it very quickly, but before that, one more question with lots of efforts to put in. Here we need to identify the fraction in each of these boxes given, and we need to say whether they are equivalent or not. Clearly look at these images. Here we have got equal sized boxes, right? And if you look clearly, we have got same part of each of these boxes shaded. Look in the first one. How many boxes do we have? 1, 2, 3, 4, 5, 6, 7 and 8. And out of 8, how many do you see shaded? 6. Okay. Now look at the next one. It is 1, 2, 3, 4, 5, 6. So it is 12. And out of 12, how many do you see shaded? It is 9 shaded. Is that right? Now moving to the next one. It is 16. And out of 16, how many do we see shaded? 12. Right? Let's move to the next one. It is 20. And out of 20, how many we have got shaded? 15. Okay. So now, how can we say they are shaded? Clearly looking into the image, we have got all these 4 boxes of very much equal size, right? And clearly we have the same part shaded. But it's actually very difficult if suppose you were having these sizes or these figures of different sizes. So it's difficult to say in those cases. Now we are going to learn some easy method to do this. Let's see how. We are going to find the equivalent fractions by using some mathematical method. Okay, rather than drawing these, we are going to use some simple math to do this. The first says multiply by the same number. If we multiply the numerator and the denominator by any fraction with the same number, then we will get the equivalent fraction. There could be more than one equivalent fraction for one fraction. I hope this makes sense. Let's understand this with the help of example. It says find 3 equivalents to 1 over 2. The statement says that to the given fraction, multiply a same number to the numerator and the denominator both. So let us multiply numerator and denominator by 2 and 2 each. So what will be the numerator? 1 times 2 is 2 and 2 times 2 is 4. So the first equal fraction to 1 over 2 comes out to be 2 over 4. Is that right? Now moving to the next one. Now let us find what more fractions are equivalent to 1 over 2. Again, let us multiply 1 over 2 by a particular number. Same for numerator and denominator. Let's say 3. So the numerator will be 3 and the denominator will be 6. So what is equivalent to 1 over 2 is 3 over 6. Let us write one more. So 1 over 2 times it by 4. This gives 4 over 8. I hope this is simple. What we were learning just here, it was so much troublesome to draw these images and then work out the equivalent fractions. Now look here how much simple the work is. We just multiply a number and the same number for the numerator and denominator, and we know that this particular fraction is equivalent, right? Let's do the other method. We just learned that if we multiply a particular number to the numerator and denominator, we get the equivalent fractions. What is opposite of multiplication is division. So we are going to divide by the same number. Okay, so this is also another method by which you are going to get your equivalent fractions. It says if we divide the numerator and denominator by any fraction with the same number, then we will get the equivalent fraction. Let's see how. It says find equivalent fraction of 18 by 27 with denominator 9. So now 18 over 27. What number can we divide each of these numerator and denominators by? We can divide them by 3. Is that right? So how many times 3 goes into 18? And how many times 3 goes into 27? So do you see that we have just calculated equivalent fraction to 18 over 27 using the method of division by dividing both the numerator and denominator by a fraction with the same number, that is 3 and 3, and we have got the denominator 9. Okay, I hope this is clear how we used the dividing method to get the equivalent fraction to a certain named, like they have mentioned it clearly that we need a denominator 9. So we have just worked this so that we got the denominator 9. Now look at this. If we want, we can further divide it. You can write 6 over 9. We can clearly divide it again by 3. Both of these numbers, they can be divided. So how many times 3 goes into 6 is 2 and it goes into 9 3 times. So here we have got another equivalent fraction to 18 over 27, that is 2 over 3. But because in the question it was asking to make a denominator 9, so this is the correct answer. Okay.